Okay. All right.
Can you not come in? I mean, your picture won't.
This is one. Yeah, I'm just didn't want to show my video today
Okay.
because I feel it's a little bit more helpful. And like I said, this one question that you see on my screen right now, this was very similar to problem number 7 on homework 6. So if you're planning on redoing the homework, which is due tonight, the homework 6, number 7 on homework 6, this problem on the screen is very similar to it. I don't want to do the exact same problem.
Sure.
But again, the session here is just to help, so I'm not giving out answer, or even if I did, I don't mind it. Like I said, only 2 out of about 58 or 60 people have got this right on the first attempt. And I'm not sure this is actually the easiest problem on the entire set. And I know the reason why people end up not getting it right is I think they were acting more like a robot, acting in a specific manner as soon as they see something. So you don't need, this problem is very easy. Well, as always, the rule of thumb stays the same. You start with the given information, and that is in, I'm going to underline it so I can re-emphasize this point. This applies to every single problem that we have done. It's asking for how many oxygen atoms. You always underline what is the information needed and what is the information given. This is given, that's what you needed. So you want to go from moles to not just atoms, but you want to actually go to oxygen atoms. That's important. I saw that one student that did get it right in my in-seat, she did this. She circled and boxed this letter. I don't know why she did it, but later when I spoke to her, I got the idea on why she did that one, because now she knows she wants O atoms, and she didn't want to forget it in the hurry that she just calculates the number of atoms. Now, this is a very simple problem. As always, you set up your given information with a 1 on the bottom. Now, if you keep in mind, what people did is they try to put the Avogadro's number here and a whole lot of things, just making it complicated. This is actually the very only one step, which is for every molecule of this CFE2CO33, there is 9 oxygen atoms, and that's all. This is for a molecule. This is how many of this iron carbonate you have, and per molecule, this is I think what people forget is that's why I try not to do too much math. Of course, I do have to teach certain math that is important from a nursing or MCAT or pre-vet perspective, which is why we are doing this, because these questions will make it to an MCAT exam or pre-vet or any of those pre-professional exams. They just go haywire with the Avogadro number. I don't know why. This problem is pretty straightforward. And as I was saying, they forget the fact this one giant thing is a molecule. That is one molecule. The question is simply asking how many oxygen atoms are there in this many molecule. In a molecule, there's 9 oxygen atoms. So this one has 9 oxygen atoms. So if you think about it, 10 candies cost $1. How much will 20 candies cost? That's all is the logic for this problem. But people were going haywire. Only 2 people out of 59 got this problem number 7 right on homework 6, sorry. That's all there is. You have a molecule that contains 9 oxygen atoms. How many would 1.3 to the 25 would contain? That's a lot of molecules. So the number should also be exponential. I'm going to leave both these methods because for some reason, I guess people can't get out, because I mean, if someone can get a 26 out of 28 like yourself, That means you know the material. But for some reason, I think people get caught up so much in that one set of mind that they forget how easy this problem was. So if you actually do the math, which I'm going to go get my calculator.
So you just multiply them?
Yep, just basically multiply. And I can't find mine. Actually, I'm going to use just the.
Okay, I've got one.
What did you get?
I got 1.215 E plus 26.
Okay, so 1.21 e to the 26 atoms. That's all is the problem. For some reason, I think people were overcomplicating it than it really has to be, so you just cancel out the molecule. So this is basically the analogy right here.
Okay.
This right here is the analogy. 10 candies cost $1. 20 would be $20. Well, that for some reason that mind can do that way, but for some reason it cannot do. It'll be $2. Exactly the same thing we've done, but because we do 7 out of 8, 6 out of 7 problems in the regular fashion. So I did not see. I figured, if I'm going to post this video, I might as well start the session with this problem in mind, so that those who are struggling, in fact, I mean, almost everyone that got a 26 missed this problem. Anyone that got below 26 missed this problem. The only person that got a 28 was the only person that got this right. So yeah, I cannot believe how easy that problem is, but that's because they forget this is a molecule. This is a giant molecule. Mm-hmm. They forget that basic thing that this is. Normally this step will be there in a long set of things, but because it's by itself, their mind doesn't seem to go get that information. So kudos to that one person that did got it right. So there's, only 2 out of 58. What are the odds? That's how many people that got this one right. Okay. So I figured, I'll take the time and walk over this so that that's done.
Okay.
Okay. And then I will now open up the, you don't need to write it down if you want, but it's already been recorded.
Okay.
So let me get my Midway screen again. So that's one thing from homework 6 that I did wanted to do. And there is something that came across, and this is something after seeing some people and they were asking questions. Let's say if this is the compound, I don't think not many people made this mistake, but a couple of people did make this mistake. They were multiplying the 3 all the way into it, and I've said that repeatedly. So if you were to get the molar mass of this, iron, I believe, is, I'm just going to rough it up to about 56. So it's 56 times 2 plus 3 times carbon is 12 plus 48. This is the way I have done it in my videos, and if you set it up this way, the chances of you making mistakes are very slim. What I have seen some people do is they multiply the 3 into the iron as well. So this is the correct. I'm going to write the incorrect way in red, so no one makes that mistake. What they did is 56 times 6 plus 3 times 3. What they also, someone else did something else too. So I don't want to, go through a long succession of things. This is incorrect. That's correct. So there's not that many people that may have done this mistake, but I do want to take the time to. These are a couple of things that people tend to have problems with. And as I said, this is a review session, so basically a couple of things I wanted to say, and then you can ask your questions. And then the other problem, for some reason, I think I've mentioned, I will not give many formulas on the test. It has to be, let's say I give you this, okay? I know this is week 3 homework, but I've said repeatedly, all my content is tied, weaved into one another, that you cannot just, that's the way I purposefully taught the class. I did not just teach it in segments or compartments. I taught it specifically so that people that want to go take MCAT or any of those exams will definitely find the material they learned helpful. And one of the reason is because of the I did not do it compartmentalized. This, for some reason, for people writing formulas out of it, we can do a couple of examples. The Roman numeral, I'm going to just say it here. The Roman numeral is only dedicated to transition metals, and there's 2 kinds of transition metals, but I'm just going to call it just transition metals. So whenever you see the Roman numeral, there are 2 kinds. One is inner and outer. It's not that important, but whenever you see the transition metal, it should remember, whenever you see Roman numeral, it should remind you of transition metal. And whenever you think of transition metal, you should think of Roman numerals. This will, whenever you think of transition metal, writing Roman numeral is important for writing a name. But when you think of given a name, write a formula, then the other way works. So this 4 is only tagged to the platinum. So it would be PT4. Now the question is, I have said 90%, 95%, 96% of the periodic table is metals. Platinum is a metal which nobody can get wrong because people wear them around their neck and their ears. So you cannot wear a non-metal, okay? Non-metals are either gases or liquids. There's no way you can ever wear a fluorine or chlorine. Or you cannot, if you go even near a bromine, you probably die from the fumes. So you cannot ever even imagine wearing a bromine necklace because bromine is such a toxic gas. The moment it fills your lungs, you'll start feeling it. So I guess I was hoping that people would understand that it is a metal, so it's positive. Metals, I'm reviewing this for 2 reasons. This is for week 3, week 2, and then anything else, except week 4 and 5. This logic would apply everywhere else. Metals means positive. Non-metals typically are negative. Typically, I use the word typically because they can be positive, but that's not the focus right here. Metals, positive. Got it. Now, oxygen. Well, oxygen is in 6A, and all nonmetals prefer to attain stability by getting to 8 when they're in a compound. If oxygen is by itself, it's 6. But whenever oxygen combines with anything to make a compound or a molecule, it wants to get to that 8. The only way it can get to 8 is to take 2 electrons. So 2. This is again entirely week 3 and a little bit of week 2, a little bit of week 6 and 7. So well, whenever something gains, it's negative. If you don't want to remember that, just remember non-metals are negative. Now we swap. So it's PT2O4. Now, I don't know of a platinum oxide, but I'm sure it can be made. So it's not an entirely imaginary compound, but it's in the ballpark of it. Now, I do know, I'll tell you what is a doctor should know, or someone in the medicine area should know, is platinum 4-chloride. Do you know what it is called, Lowell? Do you know what it's used for?
No.
It's got a common name. Do you know cisplatin?
Yes.
Transplatin, cancer treatment?
Yes.
Platinum 4-chloride.
Okay.
If this appears on an MCAT exam and you didn't know that, that is a point gone, okay? They might write a long, lengthy, now MCAT exams or any other pre-professional exams don't look straightforward like a chemistry exam. They would give you a scenario like a scientist has come up with this medicine. Well, cisplatin's been around for years, but they would give a scenario and give you this formula and have you write one of the choices. If you can't figure it out, you've lost a point, but you don't need to, because platinum is 4 plus, and Cl, just write the symbol first, and then Cl, I believe, is 7A, and it's in 8A. It wants to, again, when it is by itself in its elemental state is 7, but I don't think any element can exist by itself in a reaction. It has to combine with something, and to get to 8, it needs 1 electron, so it's 1 minus. So now we swap, we get platinum 4 chloride, and that is cisplatin. So there is a reason why chemistry is infused into the curriculum for any of these reasons, is they want to know if you can think like that on the situation. Given some random name, can you think about how you would get the formula? Again, if it's multiple choice, it's already there. But I want you to know, because as you already seen in homework 6 and 7, so many names have popped up. It's not so many formulas, right? I did try to keep a fine balance between the two, but again, I cannot always just give formulas, because those people that prepare those tests don't always make things easy for you. So this is something I really wanted to bring it up, because this is the last time I will see you on a Zoom session. I'm not going to disappear. I'll still answer emails. The last time I'm officially seeing most of you. So I really want to take this message across. And so let me rewind and do something else here on the same thing, but let's now actually pick a name. And so if I give you this, okay, let's say I give you this manganese, I'm thinking Mn3PO46. Okay, same thing. Now again, this is another thing I did want to bring up in this session, because as I have always said repeatedly, every one of your face is written on a question. I know where each of your strengths and weaknesses are. And in fact, after I finished my midterm exam for my in-seat people, I asked a few people, did they see their face on the test? And they said with a big smile, yes, we saw our face. I know which one was mine. I didn't ask them to
a whole bunch of them.
But they certainly could see a smile on their face that, okay, this was for me. And the same happened in my organic exam today in class. I asked them, did they see their face? And they all said, yeah, beautifully. We saw our beautiful face on the exam, that we know which one was for us. So I know there's a certain population in this class too that struggles with this. If I ask you, what is the charge on manganese? People again seem to go fine when, and then let's do phosphate as well, okay? If you can, let's take a similar example. If just like the platinum we did, for some reason the mind works just fine when it can do this. Well, provided it got there. Some people, that's why I started from the scratch today. Some people cannot get to this stage. Some people cannot get to this stage. So that's why I wanted to take the time to really nail this through. Now comes the third set of people in the class that now can go back. And now again, all this is week 3 stuff. People can go back. So let me rewrite the formula. I'm just going to leave a blank here for the actual answers. Let me get a different color. So all you have to do is swap the numbers back. I'm not saying everyone goes through this problem in the class, but there's a certain population that overthinks that. I think that's part of the problem. Take the 6 all the way here. Well, if you get here, like in this case, well, we're doing the reverse. There's, I can tell you what people are doing. and then there's 3 that goes here. So Mn gets the 6, the PO4 the PO4 cannot have anything but a 3. It has to be 6 PO4 3 minus. That's what it really is. But phosphate cannot have anything more than a 3, and it's a polyatomic anion, so it's negative. Even if you don't know should it get a negative, tackle the manganese. Manganese is a metal. You know, that's in your omeprazole. It's contained manganese. That's the key ingredient that prevents the heartburn. So manganese 6, well, manganese is a metal, so it has to be plus. So this has to be negative. You can also do it by that method, even though that's more of a primitive method, but it still works. Like if you figure out one is positive, the other has to be negative. It cannot be positive at all. And what I have seen some people do, this is correct. I am again going to write the incorrect answer in red. They have done Mn3 plus PO4 6 minus.
Oh my.
Okay?
Mm-hmm.
So whoever's watching the video can now smile because they are seeing their face on that. All right? I'm not saying everyone did it, but there's a couple of people in my in-seat class also had that same problem before the test. We had a 2 practice exam session before we actually had our exam yesterday. Everybody did well, but unless I have done that practice exam review for 2 sessions, I wouldn't have picked this up. This was a casual mistake that some people were making, even though they all got a perfect score on homework 3. So avoid doing this, do this. Now, these are some foundational things that I still see people struggle with. And again, I cannot re-emphasize, only Roman numerals get the transition medal. So what I would do is, now this might be for someone that is making that kind of mistake, is I will give you this. And guess what? You can expect a choice like magnesium 2 chloride. I would purposefully throw that in there because the mind does not relate that magnesium is a metal, but it's not a transition metal. So if I give you this as choice, trust me, there will be still some people that will go for it. It's like a bait, you know, like a hunter sitting with a bait. People go, the animal falls for that trap. I will let this trap sit, and trust me, people will make that mistake. And you cannot make this kind of mistake if your target is finally medical school or a PhD in psychology. You cannot make this mistake. Or I will have one more choice, magnesium 2 dichloride. Make both worlds happy by giving both the Roman numerals and the dye. No dye for ionic compounds. And what is an ionic? That's another question. Whenever it's a metal and a non-metal, that's ionic. So you cannot ever use no di, tri, tetra, etc. You cannot ever have them. So the correct answer is this. But trust me, I can have at least one person in every class that will go for one of the other choices. Because the moment they see metal, okay, it's 2, Roman numeral, bingo. Or they go magnesium dichloride, oh, there's 2, so it's got to be di. Or magnesium 2 dichloride, that's for people that are happy with both the transition metal world and the dye world. It will make them happy. They see, oh, I got both, best of both worlds in it, so I'm going to go for that one. All of these are wrong.
But that is because chloride is always
1 minus.
1 minus.
Yeah, but this is contrastingly different to this compound right here. I'm going to pick a different color so I can actually answer that question. In this compound too, Cl is 1 minus. Cl is always 1 minus.
Always.
But guess what? I mean, this is a non-metal.
Right.
This is a non-metal. When you have two non-metals, now again, I'm refreshing, I'm going to spend the first half an hour or so refreshing common mistakes people have made that I've observed from week 2 onwards through week 7. That's all I'm doing now, and then I'll leave more questions for week 7. This is a non-metal and a non-metal. When that's the case, you use dye. So nitrogen trichloride.
Right.
Same Cl in both scenarios. I mean, in fact, this was one of, very similar to this type of compound was in one of the quiz questions. And if anyone remember it precisely or vividly well, they can definitely see that they will go for choice A, because the moment they see a metal, they want to go put the Roman numeral in. No, Roman numeral is only for transition metals. And ionic compounds or anything with a metal, you cannot use di or tri, period. Even whether it's ionic or something else, if it's got a metal, you cannot use di, tri, etc. Only that is reserved for two non-metals. So this is something I noticed, and I've been observing people, and I'm not saying everybody does this mistake, but it's important that you guys understand that. And I've seen a couple more people have joined. Welcome. Can you hear me? Kelly Brandon, is it?
Yes, I can hear you.
All right. Christina? Okay, I think she'll say yes when she hears me. All right. So now I'll open, Kelly, so far I have reviewed some common areas of mistakes that people have repeatedly made. And I'm recording the video, and if you go to the first part of the video, I've answered that question that only one person got it right on homework 6, which is problem 7. It seems like a bane to a lot of people. I've answered that question and how to solve it, okay? All right, now I will open, those are some common areas that people still, even though they have done well on every single homework or quiz, they seem to somehow not take the time. I think it's more of taking your time. Now, again, I'm giving you 2 hours. That's plenty of time to take my test. I'm not sure that'll be sufficient to take an MCAT exam, but it's the 2 hours that I'm giving you is a lot more time. You should be done in 40 minutes, so you should technically have about an hour and 20 minutes left. So taking the time with each question, paying attention to detail, that's the difference between an A and a B and a C. I don't think anyone will walk into a test not knowing anything. It's just paying attention to the detail. So if you see those two things on the screen, clearly how you approach them has to be completely different. And so going back to that one thing that I was saying, now if I ask you what is the charge on chlorine, well, if you can go forward swap, you have to do reverse swap. Just put a 3, there's nothing here, so it must be 1. So let's put a 1 here for time being, so that goes there. So N3 and Cl is 1. Well, this is a little tricky. I mean, not tricky as in, but there's other resources you can use. One is the electronegativity table. If you run into the situation where both non-metals and you don't know which one to give the negative, go look at the electronegativity table. From my experience, I don't need to do that. I can tell right away. You can give me hundreds of these and I will finish them really quick. Go look at the electronegativity table. Whichever one is more electronegative will get a negative charge. More electronegative. I'm going to write text messages here in lieu of space. More electronegative gets a negative charge. And if you've already looked at the periodic table, you would have noticed chlorine's got a higher electronegativity value, so that gets minus, this gets plus. Remember I said non-metals can be positive, and I said the word typically. Metals cannot ever be negative. And there is no human being that can make it. I can tell you that much. I mean, that's like creating a whole planet. There's no one that can do that. And if a human being can make a metal negatively charged, he or she will receive Nobel Prize the next day. It is impossible. It's not even a question of if it's possible. It is impossible. That's like violating science, violating nature, and that's impossible. So keep in mind, the reason I say that little story is metals can only be positive. Non-metals are usually negative, but can occasionally be positive, and this is one case. Is that clear, Lowell? All right. Now let's move on to answer any questions that people might have, particularly about week 7. That should be the focus, and you're welcome to ask any questions. I may not solve the exact same problem on a homework, but you can ask me just the concept and I will come up with the problem on the spot, and we can work it out. That should be a better way to learn it than actually working out the same problem. Or if you have any other questions too, you're welcome to ask that.
Well, I don't know. I'm just having trouble with all of 7.
Okay.
And I've gone back and watched the videos, and I don't know why all of a sudden I've just hit a big stop on the solutions. But it seems like I don't process the question, and then, I mean, I did really poorly on the practice exam because
that was the purpose of the practice exam, was to.
I did that well then, because I did terrible on the practice exam.
Yeah, practice exam is practice, Lowell.
Oh, well.
You don't need to be super good at it, but you want to get good at it. So the purpose is you want to be really good at it. All right. How about I give you a problem? Tell me again, just like last time I did with you, Diana and Peggy. I don't want to solve the problem. I want you to tell me, as I think Socrates said, I cannot teach anyone. I can only make you think. Okay. That's the way I see my philosophy in a classroom. I cannot teach somebody a chemistry course. I can make them think through that process. They learn the chemistry they want to learn, and then be happy with their MCAT exam or pre-vet, wherever they're going, their life's taking them. All right, so how about I give you this? Calculate. This is the foundational problem, so hopefully you get this one right. Calculate the molarity when, say, 0.5 grams of NaCl was dissolved in 250 mils of water. And you don't see the word density. That means you have to assume that it is 1, and basically you have to say that the total volume of the solution is 250. I can draw actually an analogy to help you. I think I have done it in one of the video when I taught this first time. So this is your 250 mils of water. Okay. I'm drawing it more pictorially, the question. And you are going to add 0.5 grams of your sodium chloride. So this dot is your sodium chloride. If the initial volume and the final volume are exactly the same, this is, I'm going to call it the final volume, and this is the initial volume, which was my red. If these two are exactly the same, that means the density of the solution did not change. That 0.5 grams we added to 250 mils of water, it did not change the density. Because if density has to change, either the mass should change or volume should change, right? But in this question, I did not bring up the word density at all. So what that means is, after I added a point, think about it in your daily life. You go to Starbucks. I'm bringing Starbucks because that's where I go. You get coffee and you add your creamer, except when you add your creamer, your volume doesn't go just because you add your sweetener, right?
Right.
Does your coffee volume grow incredibly large quantity because you add like 10 packets of sweetener like I do? No. Even a 30 packet of sweetener will have no impact on the volume unless I actually had cream, right?
Right.
But if I had, say, like the entire sweetener company into my coffee cup, then yes, there will be a significant change in the volume, right?
Right.
What that means is only when the question mentions density, you have to worry about an extra variable. If not, you're going to say you just have 250 mils of solution. That's all. 250 mils of water becomes 250 mils of solution. Okay? I'm just transforming this information because I did not give you density. I only gave you, I did not give you, what that means is when I had this half a gram of table salt in 250 mils or a cup of water, it basically did not change the volume. What that means is my solution volume is now 250. Okay?
Does
Now
density always,
what's
does,
that?
does density always refer then?
Yes, density will be given to you if it is needed. Now in this problem, all you have to do is first write what is needed. Again, I'm going to switch colors here. First, I think you have to write, I think for what scientists or people that learn science do is first you got to figure out what is the question wants you and what are the given pieces of information. This is the first piece of given information and this is the second piece of given information. So I always start from the question that you wanted to solve. So molarity, first write the definition. That's the starting point. That's at least get you into the problem, at least a footstep into the problem. Molarity is moles of solute over a liter of solution. Now you would wonder why I mentioned about the milliliters of water to milliliters of solution. Are they the same? No, the numbers are the same, but the concept is different. Water is just a solvent, and solution means it also got sodium chloride. So Lowell, the first step to do is to write the definition. That's your step foot into the problem, okay? I've repeatedly emphasized that, okay? You have to write the definition first. That's your footstep or into the door. If you don't write this, the problem would always look glaring at you like I don't want to do it or I don't understand it kind of a feeling. In fact, you know how to do it. You just don't write this definition, then you would not get there. All right. Now with that said, now we don't know, we sort of know the bottom portion, but we definitely don't know the top portion. What do I mean by bottom and top is we've got to figure this out before we can put them into this expression. And when we are done, this is all should be the unit that should be left with. Means chemistry is just another branch of science. There is no magic, there's no black magic, there's no voodoo, there's none of this stuff. It is science, okay? I cannot teach you some magic techniques. You should be end up with this. If you don't end up with this, well, then you have a problem. More likely, your answer will not match the answer I give you. So, first step first, moles of solute. How are we going to get? Whenever you're given ooh, that's really white. Okay. I guess I went outside my canvas. So, whenever you're given grams, I don't think you can work directly with grams unless you calculate density. Whenever you're given grams and you want moles, which is what clearly says on the top, you have to use the molar mass. That's it. And whenever you're given moles and you want grams, you still use the molar mass. It's just how you use them, whether you put it at the top or bottom, it differs. But this is the first case scenario right here. We've got grams and we have to get to moles. That means we have to find the molar mass of sodium chloride. And sodium is 23, chlorine is 35, so it's 58 grams. Now, I've said that in my last Zoom session and even in other videos. Chemists don't write things like normal people do, okay? Chemists think like chemists. That's why I said that book that you have for the class is not written for students, it's written for chemists. That's why I recommended none of you use it. because there's so much technical jargon in it. I recommend you write it this way over this way. This is how a chemist would write. That will be of no help to you because it's hard for students to translate this piece of information into a calculation. Whereas if you start writing it this way, it makes life so much simple. All right. With that said, let me move my little screen out of the way so I can actually perform all this calculation in one go. Okay. There's two sets of calculations you have to do because we want two sets of information. All right. So the first one is we got 0.5 gram of NaCl. That's one of the given information. So use the first given information in the far left cell, put a 1. Well, we want moles, and we know the molar mass is grams over mole. So the mole goes on the top, and the 58 grams goes on the bottom. And then we get the moles. Can you get me that number below? So it's basically 1/2 over 58.
Yeah, my computer
Whatever
died.
that adds up to.
Okay, I'll get it. My computer died.
That's okay. Let me, I also got my calculator, but for simple calculations, I should be okay.
Yeah, let me use my phone.
Yeah, it's about 0.0086. That's roughly. Don't worry too much about sig figs. I did not really teach you that much of that concept.
Yeah, it's
So 0.86. All right. Now, this is something that's worked for one of the girls in my in-seat class. I started having her bring color pencils to class. I mean, that is a leap in a chemistry class. You don't see that often. I told her, bring your color pencils. And I have her box different pieces of information with different colors. I mean, you see my screen, it looks like a garbage plate. There's just things everywhere, but everything is different color. So I don't write one blue or one black or one red. Write things in different color. All right, now what do? I cross out this cross question mark because I no longer have a mystery about this moles of solute. I now have this information. Now, this is tricky because the reason density is not given, so we are going to assume that whatever your volume of water is, that's how many will be the volume of the solution too. But it's important that if you look at my answer choices, I would have simply divided this by 250 just to trick people in, and they will go for that. But this is in milliliters. This is in liters. So you have to convert that. And I believe on the test right next to the question, I have provided all of you with the necessary conversion factors. So you don't need to Google it or go look for it someplace else. It's right next to the question. So 1000 milliliter is in a liter. So 250 mils would be 0.25 liters. I can do the math, but if you wish, I can avoid it. But you know what? I'll help everybody else out with this. So you have to do I do this all in one step, but I have not taught any of you this in one step. Simply because if I teach you one step, you will again be back to square one. Where do I start? Because I teach it as two separate components, now you know you need two pieces of information. So it helps more of learning better than doing it all in one go. Again, there's no right or wrong way either. So it's 0.250 liters. That's my second piece of information that I'm going to box it with some other color. Okay. And now I don't have any mystery about this information. So now I know the top and the bottom. So let's move this out of the way so I can do my calculation here. So we're finally in the very last stage of the problem. So molarity equals 0.0086 moles over. We did exactly the same thing in the last recorded session too, but I think because we're getting really close to the exam, it's worth just to walk over this. So now you do the math and you will get the right answer. Okay, 0.034 molarity. That's the concentration. Now that I walked you through the entire problem, where do you think your potential pitfall areas are?
Me?
Yeah.
I don't
It
know.
doesn't matter. Any one of you can answer. If you don't have a problem, that's fine. But
I
if you
have a
have a,
problem.
you're good now, Lowell?
No, I have a problem. My
Okay.
problem is that I don't know once I've done one calculation what I've got. And I think it's because I'm mixing up whether density is a volume, whether uh, if my sodium chloride's my solute. I think I'm not connecting.
Okay. Your substance with the chemical formula is always going to be your solute. Okay. I'm not teaching organic chemistry to guys, so I don't even use a solvent other than water. So by default, water is the only solvent for this class, this entire class.
Okay.
Don't teach you organic chem. If I do, yeah, I will tell you about the various organic fluids there is, like cyclohexane, butane, cyclobutane. There's so many different things there is in organic chemistry, but in general chemistry, there's only one major solvent, and that is water, at the worst ethanol. But I've not even tested you on ethanol. Okay?
Okay.
So when your question does not say anything about density, don't think about density. That's the easiest way I can tell you. Don't even think about it. This question does not have the word density, though there's only one thing with the letter D, that is dissolved. So if density is not there, don't think about it, okay?
Okay.
That's the best solution I can give you. Just don't think about it if it's not there. All right? Let me take a time to go walk over something very simple, but I think that seems to be of some issue to some people. I'm not saying to everybody. You don't need to write this down. All this is recorded. I will post the session shortly after we're finished. Okay? Now, this is something, again, this is more of, you should be able to visualize what's happening. Okay? How much water is needed. I gave even a mathematical formula, but people stop after they use the formula. They don't think beyond that. How much water is needed to dilute 250 milliliters of, say, all these are made up numbers, HCl to 0.005 molar HCl. This is a dilution problem. I dedicated an entire video in my video series for this because I didn't want to confuse this with any of the other concepts. As with any other problem, you don't just jump in and start working out a problem before you actually got to figure out what is that you need. All right, how much water? Well, water is a liquid, so we do need volume of water. So write volume for now, because people still can differentiate between volume, mass, weight. They're all different things. How much water? Water is a liquid. Unless I say it's ice, then it's a solid, but otherwise it's liquid. Is needed to dilute. This is another key word. We'll get to that in a little bit. That's of no immediate attention. It doesn't need immediate attention, but it needs some attention down the road. And then we got set of information. This is how, no matter where I go in the rest of the world, even if I go sit on top of Mount Everest, I would think like a chemist. And I would write it this way. Even if I'm on my deathbed, I'd write 250 mils of 0.1 molar HCl. My brain is just ingrained with that, okay? So I cannot write a test with this information written differently. That's like how a doctor is told to use a stethoscope, our nurse is told to hold a pulse. Do you change that? Probably not so much. Once you learn it, you learn it. Just like that, 25 years ago, someone told me, hey, you got to write it only this way. This is the correct way. 250 mils of 0.1 molar HCl. This is the way this information must be written. It cannot be written any other way. To this information. These are all technical ways of writing. I cannot change what's within this little bracket here. What this means is, I know this is what I'm starting with. I called it V stock, means volume of stock, means this is what I'm starting with. You can call it V start if you wish. This is the concentration. I'm going to call it C stock. Stock is for start, or V start, C start, whatever you want to call it. This is what you're starting with. You're ending with the concentration. You just need to find the end volume. So I'm going to call it end concentration, C end. I know the end concentration. I just need to know the volume end. That's all. I know this, I know this, I know this. I just need to know this. First, there is a formula called V stock. You can use it the same way. You can come up with your own letters too. But this is kind of basic. V stock times C stock equals V end times C end. I believe there is a problem in, hang on a second. I got to connect my computer with power. Okay, this was in the dilution video I have made, and I think we didn't get this far in the last one because we were focusing primarily on week 6. So you've got to remember this formula. Whenever you see the word dilute in the question, okay, this is what you first go to. This problem doesn't end the moment you solve this equation. There's one little step. That's what I meant by we're going to pay attention to the dilute after we finish this step. You don't need to convert milliliters to liters, none of that, because again, basic algebra, like things cancel. V stock is 250 mils, C stock is 0.1 molar, V end, we don't know, let's call it X. C end is 0.005 molar. This is very similar to, I think, the penultimate problem on homework 7, or it was the last problem. I can't remember which one was which one. So let's find out what this V end is. So it's basically 250 times 0.1 over 0.005. This problem doesn't end here. I mean, this is almost a standard problem on any pre-professional exams, because any medical institution that hire you as an employee wants to know at least you have a basic idea about dilution of anything, any medicine that's in a concentrated vial. So this question is almost guaranteed to be on any pre-professional exams. Mils. Okay, this is not what the question is asking. It's asking how much water is needed to dilute 250 mils of 0.1 mil HCl to 0.005. This is the total volume. Let me draw it visually. We're not done with the problem. We are starting with, say, 250 mils of 0.1 molar. And we want to be at 0.005 molar when we are done, and we just determined that whatever the space from here to here will be totally 5,000 mils. This total volume is 5,000. That's a terrible handwriting. Let me redraw that. I want people to understand that. So this total volume will be 5,000. But that's not what the question is asking. How much water would you add to the 250 to get to 5,000? So all you have to do is to get the dilution, that to actually complete the problem, just write dilute amount or something and say V end minus V stock. That's where the problem is completed. Of course, there will be a 5,000 as an answer choice. If you go for that, you're just like a prey, just waiting to get sucked in, and I will be ready for that. So it'll be 4750 mils. So now I'm going to come back to my drawing. So your total canister or container, whatever you will have, you are going to make 5,000 at this concentration, but you're not going to add 5,000 on top of 250. You're only going to add 4750 because there's already 250 of water sitting. So you only add 4750. So for a question like this, from my experience, there are 4 choices. A, insufficient information provided. Standard on. That's why I'm trying to follow the format in several of my quizzes and exams. Insufficient information. 5,000 mils. 5,250 mils. D, 4,750 mils. And E, none of the above. People like me know where students think. That's why I'm teaching the class. They were assigned me the job to teach the class. Okay? This is how that question will be if you take this exam. And everybody will just plug in that formula. If they have gotten that far and they see the 5,000 there, they immediately go for it. Some people overread the question. Instead of diluting, they overdo it. They add the 250 to the 5,000, so they go to the other side. But we are trying to fill this void. That's already 250 sitting here. You have to get to 5,000. That means you only have to add 4750. Is that clear, Lowell?
Yeah, I get it when you do it, but I just get confused when I do it.
No, this was only one video that I created for dilution because I know I was not going to test you a lot of concepts around it. Just like, I think there's 2 problems on homework 7, I believe. This is directly related to the very, very last problem, I believe. Or both of them are the same thing. I can't remember, but the last 2 problems, I believe, on homework 7 has to do with dilution. And one of them is almost a ditto copy of a photocopy of this. I'm not sure if the numbers mean anything. But the point here is, you see that multiple choice that I just created right in front of your eyes. That's what professional organizations that create medical exams or exams ask professionals to create the exams. The doctors themselves don't sit and write an exam, so are the nurses or the pharmacists. They don't write the exams. It's people that are professional in the area write the exams. But they will be given criteria on this is what we want our students to critically think and pay attention to detail. And so we get some restrictions on what we can test. We cannot just give you an organic chemistry exam and have you do it. That's not possible. But this is simple. This is what the students would think. That's what their mind thinks. I would say 80% of students that answered this question will go for choice B. C, the remaining 10% will go for C. The remaining 5 out of the 10% will go for A, and 4% will go for E. Only 1% will go for D. So only 1 out of every 100 people that take a test will get this question right. But is this really a difficult problem? You think it's a difficult problem, Lowell?
Well, I don't think it's the way you do it. I mean, if I was in seat and sitting there talking, I mean, I understand it when you say it. It makes all the sense in the world. But when I'm sitting there with a piece of paper, I look at it all and I go, oh my gosh, what did he just ask me?
Yeah, this is one thing I did really want to drive during this session today, because I don't know how many of you got to the very, very last video in week 7.
Oh,
That
I did.
that was purely dedicated to dilution. But this problem would help you. This equation is what you need, and then you need to know that these two what you need. Now, you wouldn't need to do anything. Let's modify this question. That's the thing. When you know your content, you can manipulate it. That's for your area too. If you're a really good
So,
nurse.
may I ask a question first?
Yes.
So the final answer of 4750 mLs, is that molarity, or is
No,
that
no, no. That's volume, milliliters.
okay? So it's
All
just
right.
total.
Now, if you write the question the other way around, what is, now typically this is how they write it. Again, there are certain technical ways we have to write a test. We cannot write it the way we can teach it in layman terms, but when we write it, we have to write it in a certain way, because there are some ethics to writing a test, and you can't just write it all layman. What is the final concentration when 250 mil of zero point 0.1 molar HCl is diluted to 47 or 5,000 mils? That's it. This is really classic. I basically took the answer from the previous equation and applied it as the answer here. Whenever you have a final concentration, if the question is asking for final concentration, you do not need to subtract or do anything. Once you finish with the equation, you're done with the problem. It's only for the volume you have to make that difference. Okay, Lowell and Kelly?
Yeah.
K stock equals V end times C end. You need to understand V is volume, C is concentration. Let's go get these pens. So this is what, as I said, see, I did it out of practice. I'm not doing this. I did it purely out of practice. That's the way my hands write. This is the way a chemist would write something. So 250 mils of 0.1. Whenever you know a volume and a concentration, that's your V stock. And anything with concentration is C stock. Anything with mils is V, anything with M is C. And we know the V end, we just need to know C end. That's what we need to find. In this case, whenever you're asked to find final concentration, I know what it is. I think one of the homework problem asked for final concentration, the other one asked for how much water. Now I know. I think that's what I was getting at. I think the one I did previously was very similar to the last problem on the homework. This is very similar to the penultimate last problem on the homework. Whenever you're asked to find final concentration, again the word dilute comes. There is a certain way a chemistry question has to be written. No matter how hard it is, how easy it is, it has to be followed a certain format. And whenever you want concentration, you do not have to do any more other than simply put everything in place. 250 mils times 0.1 molar equals 5,000 mils. No need to convert, nothing. Just straight plug-in chug algebra, and that's it. Solve for x, and that's your answer. Do we even need to do that? I think I know what the answer is, because it's just the opposite of the previous question. It's 0.005 molar. I don't need to even do my math.
So that is the molarity of the.
Yep. That's the final concentration. I believe this is the problem that was last on the penultimate problem on homework. I believe the one after that is like the one before. So when you're asked to find the concentration, final concentration, you don't need to subtract nothing. You can stop. Again, I may have, wrote something in a chemistry term, but if you see that I did not just, got on, like a madman car and just drove, had high RPMs. I went systematically about my business. I put arrows towards information I wanted, and I gave them the same legend on what's in my equation. I didn't just write some arrows or some random things. I wrote specifically V stock, and that information corresponds to V stock here. C stock, VN, VN. Now, this is a really vital skill to have, just to, even for your household. If you get a really concentrated bleach or concentrated detergent from stores, most people just put randomly things together, hope it's diluted, but you don't need to do that anymore. All you need is a measuring cup from a dollar store, and there you are on your way to precisely dilute your bleach or your detergent rather than just eyeballing it. So whenever you're asked to find final concentration, you can stop right here. When you're asked to find the volume, that's when you subtract the V end minus the V stock, or V stock minus VN. You just cannot have a negative value. You just have to make sure of that. I don't think that will ever happen. It's usually V end is bigger than V stock. So you always subtract V stock from VN. So these are the two problems that I believe I have given less attention, even though I dedicated a whole video, but I figured, I'll take the time to walk you all through this, because not everybody did bad on homework 7. There's some people that have turned it in, and I haven't graded them yet, but I've looked over them. But I know that these two problems are the last two problems on homework 7. And you can expect something like very similar or similar along those concepts on a test. Okay. Now, there is one thing, or actually I can ask you, do you all have any questions for me? We got about another 15 minutes left. I will answer any other questions you have on anything, homework 7, 6, 3, 4. I'm open.
I have to log off. I have to go get my daughter, but I was going to ask you about this question, how many oxygen atoms in 2.5 grams cobalt-3 phosphate?
Okay.
That was one that
Okay. Can you
I think it was on the practice test.
that
I missed it, and I went back and tried to do it. I couldn't figure it out.
Kelly, can you repeat the question for me? Can you repeat the question?
Yeah, I don't think my connection was very good. It's how many oxygen atoms
Okay.
in 2.5 grams cobalt-3 phosphate?
Okay. Now again, I did a very similar problem before you logged in, but that was kind of leading into probably something like this. It's called cobalt-3 phosphate, right? You said?
I can just go back and watch the video.
No. Cobalt-3 phosphate is what you said, right?
Yes.
Okay. Now this is like your croissant or some other kind of phyllo dough or pastry dough. There's got multiple layers to this problem. Got to tackle one thing at a time. First, again, as always, the rule of thumb is you got to figure out what it is the question asks you to calculate, and it's asking for oxygen atoms. And what is the given information? It's mass, right? But this problem is a lot more harder for people if they can't figure out the formula. Okay? And as I was saying earlier, the Roman numeral is only tagged to the cobalt because it's a transition metal, and metals always get positive. And this phosphate, if you go to that list I gave you, it's really minus. They're both plus and minus, so they cancel out. They're equal. So it's COPO4. Please make sure to put it in brackets so you don't confuse this for an oxygen. I have seen that happen. This is cobalt, not CO, like in carbon oxygen. This problem is easy like any other problem, but the reason why some people may not get it is because of the pure fact that they cannot convert this name into a formula. And that is the first layer of your phyllo dough. And if you can get that far to here, well, you've got the first layer down. Okay, I'm going to draw, this is the first layer down. The second layer, as always, you got to go get the molar mass. That's your second layer, okay, which is, I believe cobalt is, I'm not that smart to remember the periodic table, but can you get me the molar mass?
No.
It's 58.
Okay, so 58 plus 31 plus 64. So that would be what? 5, 8, 13, 1, 9, 14, 153, right? Right? 153 grams over 1 mole, right? Is that correct, Kelly?
Yes. Sorry, I'm behind on your writing. I can't see what you're writing. I don't know why.
Oh, it's okay. It's not your fault. But you are seeing it, right? You're seeing what's on the screen, right? All right. So
No,
this
I
is
can't
the
see.
second
It's
step.
like 2 minutes behind. So I'm still seeing just your question at the top, and that's all.
Oh, okay. Yeah, it's probably your internet is a little bit behind. That's probably what it is. But
Yeah.
you can see it. The first step is writing
If
the
you just write it and talk about it, then I can go back and watch it.
the formulae, and then the second is getting the molar mass. The third step is the actual calculation that we have to do. So if you miss any of these layers, you can do them in any order you want, but ideally, if you don't have a correct formulae, you won't have a correct molar mass. That means your calculation is going to be skewed. So the first thing with any of these problems with a chemical name is to write the formulae, get the molar mass. Now the final phase is we write the given information, which is 2.5 grams. Write one. Now, whenever you have grams, if you remember that sequence, to go to atoms, you start with grams. So your first step is to get it converted to moles using molar mass. The second step is whenever you're asked to calculate just atoms, you are welcome to use the 6.023 to the 23 atoms. But whenever you're asked to find a specific element, then you don't want to use the atoms itself because that curtains your problem. You want to continue. So I would use this conversion. Whenever you're asked to find a specific element like oxygen or iron or carbon, a specific element in a molecule, then I suggest you use this one over just conventional atoms. And then you will end up finally with your conversion of whatever the number of atom is. I don't want to put it there now yet. So first step is moles, molar mass. 153 grams goes on the bottom, 1 mole goes on the top. First step done. Let's go get our blue and cancel these out. Again, doing systematically, writing a unit. I know I have seen some homeworks that they did not have anything. They just have 2.5 over 1, 1 over 153. It might serve you well sometimes, but it's not going to serve you well all the time. The method I'm teaching you would serve you well every single time. So cancel out the grams, write the units. If you don't write units, you don't have any idea what you're even canceling. Now we are done with this process. Moving on here. As I said, you have two of these. I gave both of these. They look exactly the same. The only thing is one has atoms, the other has molecule. You would use the bottom one when you're just asked to find the total number of atoms. When you're asked to find a specific element, how many it's there, you use the top one. So now I write my mole on the bottom, the 6.023 e to the 23 molecule at the top. Now, the reason I write the unit is because, again, as I said, this COPO4, this is a molecule, one molecule. You cannot forget that. I think some people forget the fact that it's actually a molecule. So that's why they try to play with this bottom portion, but then their answer never matches my answer. That's because they forget the fact this is a molecule. Now that's why we are even using the top, not the bottom. Now we are down to the last phase. A molecule of this contains 4 oxygen atoms. So multiply by 4 O atoms. Now, the sequence that I drew, it's not in your book, it's not on Google, it's not elsewhere. because this information in your textbook is scattered all over your textbook. It's not specifically put in a sequence like that. So if you Google this sequence on Google or Yahoo Mail, or anywhere you go search engines, don't give you that specific image, because this is something I've created over the years just with the pattern of things that happens. It's more generic. It works 99% of the time. Now let me go get my blue again and cancel out the reminder. So moles, molecules. All I want to be left with is atoms, and that's exactly what I'm left with. Not just any atoms. The question wanted O atoms, oxygen atoms, and that's all I'm left with. Now if you do the math, you will get the right answer. Can you do the math for me? One of you can do the math and tell me what the number is.
It's 2.5.
Let me do the calculation myself so I can verify if y'all get the same answer. So what did you guys get for the answer?
I didn't get it just because of my other computer. My calculator.
I'll get it. I'll get it in just a second. 2.
But it's going to be 2.5 times the 6.023 e to the 23.
Exactly. Yeah. Let me write it. So 153 divided by times 6.023 exponential 23. I'm doing it on my computer calculator because
okay.
I don't trust my cell phone as much.
No, I don't either. That's why I'm not using mine.
Okay, so here's what I got, Kelly. I got 3.93 e to the 22. Somewhere in that ballpark. Is that what you had?
Yes.
Very good, and that's how you do it. And I purposefully do it name, not formulate, because again, you need to, if I don't do it now, you would never remember week 3 ever again. And if you're going to take any of the exams, they don't always give you formulae, they give you names, because they believe that every medicine on the back of it, of a medicine or food container, doesn't have formulae, it only has names. So as nurses, you should be able to tell the difference between manganese sulfate, magnesium sulfate. If a doctor tells you to give sodium chloride, you accidentally grab lithium chloride, that's a lethal injection. So instead of helping a patient, you're going to kill a patient that comes to you for help. So they want to know that when they hire you, that you're prepared to handle some of the basic job tasks, and that some people, even after chemistry class, can't tell the difference between sodium and lithium or magnesium and potassium. They confuse everything. So potassium chloride is used in, sorry, I mentioned lithium earlier, sorry, it's potassium chloride is used in lethal injection. Sodium chloride is used as your dehydrating, typical saline solution. They're only one element apart, but one can kill you, one can save you. So as a nurse or doctor, I think you should know basic formulae and names. And so that's, I think, the reason why I keep emphasizing that. If not, you will forget it by the time you ever take one of these tests. So did I answer your question, Kelly, on that particular question?
Yes, you did.
Okay, very good. Lola, are you good? I know you're never happy. I cannot ever convince one person in the class. That's Lola Larkin.
What?
I cannot ever make Lowell happy. I know she smiles, but I don't think I made her happy.
No, I hope I keep it
Lowell,
together for the test.
I think you're in the top contenders in the class for good grades. So I think you should not.
But I'm going to freak out, I freak out over tests. and then I sit down and then my brain goes blank.
Do you have a dog or cat in your house?
I have multiple. That's why I keep muting my.
Just have them around when you take the test. Maybe it'll keep them happy. So don't try hard. Don't try hard at anything in life. It's not going to work. If you try hard at anything, it's going to go away from you.
I'm afraid of that. If I fail this test, I hope I still pass.
If you treat chemistry like a trash, it comes to you like a charm. If you treat it like a charm, it's going to treat you like a trash.
All right, I'm tossing this thing way down the river.
That's actually not a bad idea, actually. If you toss everything that's reminiscent of me and chemistry, you probably will have a better time doing well on the test. Just don't hear my voice before you take the test, just, because it might bring some earthquake in your head. Just don't listen to anything chemistry. Do something else in your daily life or do something else. Even eat, sleep, something, but don't just watch a video and take a test. That's a very bad practice. Don't just watch a specific video and jump on to take a test. That's a bad practice.
Oh.
Just don't watch anything chemistry related when you're about to take the test. Keep your mind clean. And as I said, the test I'm anticipating, I can tell you there are 30 questions total. 25 is what graded, 5 are bonus. Each question is worth a point. So if you do the math in your head, 25 times 0.9 is an A for just the exam part. So that means you can miss, I think, up to, you only have to get an A on that final alone. You only need 22, roughly about 22 out of 30. So you can miss up to 8 questions and still get an A. You don't want to go below 8, then that's a B. I don't do partial credit. I don't do curve. I don't do any of that thing because it's nothing to do with learning. You know it or you don't know it. So there are 30 questions total, 2 hours long. I'm saying this for everybody that will watch the video later, so they're prepared for it. 30 questions total. Each question is worth a point, and 25 is graded, 5 is bonus. And if you have any bonus from previous exam, that will also be added to this. If you have no bonus points left from previous exam, then you just get to keep your current score.
Okay.
Let's say if you have 1 bonus point from a previous exam left over, that means you only have to get a 21 on this exam, and I'll add that 1 point to this. And then still that homework 1 and quiz 1 is still there. People that just blindly pass with an A, they don't need that. But people that are struggling between a better grade, I will help them out there with those points. Again, it's not like granted because it's an excluded grade, but for people that are already A or going to get an A, they don't need that. Because no one's going to care how many points you had for an A in your transcript. They just need to know you have an A. So only for people that needed, like, say, 5 points to go from a B to an A or a C to a B, then they are welcome to use that points to go to a better grade. But again, I am anticipating 40 minutes test time out of 2 hours, so you still have about 1 hour and 20 minutes. So take your time with the question and work each question. Pay attention to detail. Don't miss the detail. If you miss the detail, that's what the difference between getting the question right and getting the question wrong. Paying attention to detail. If you're going to be a nurse or a doctor, you got to pay attention to the little details. You cannot just look at the big picture all the time. You got to look at sometimes the details too. So I have walked through, if you watch back this video alone again, I have summarized some key areas. I have observed people make mistakes. I've reviewed them. And then I've answered some questions on week 6 and 7. So I wish you all good luck. Don't forget to do that course review thing.
Okay.
It's somewhere in week 8, I believe. I think that's the only thing that's there in final exam, I believe. Now this recorded session will also appear. I gotta, go to Starbucks or some other place to upload it because my home internet is not that fast for an hour and a half. This video is 1.5 hours long. It takes about 2 hours for my home internet. So I will upload that tonight. And the test opens tomorrow morning at 6:30. And I will post the homework 7 key. That's homework 7 redo is due on Friday. So I will not accept any more redos after Friday midnight, because by that time I would have posted the key for homework 7, and then you can take the exam over the weekend. Where you have homework 6 key is already up. Homework 7 key is the only one. It's already there. You just can't see it. I've hidden it because I got to wait for people to turn in their homework 7 tonight, and redos are due on Friday night. And I got to give your final course grade onto the registrar on Monday morning. So I don't have a lot of time. So make sure you have your exam done by Sunday midnight. Okay?
Okay, thank you so
By
much.
end of day Monday, I would have handed over the grades for this course to the registrar, so I don't have a lot of turnaround time. So make sure that you get the things done and turned in on time. And also do me a favor, to both of you and anybody else watching the video, go through all your scores, make sure everything looks all right, that I didn't miss anything. But again, if you've not turned in, there will be no grade, but otherwise just check everything for good measure, just every column in your grade book. Okay?
Okay, thank you.
All right, good luck, folks, and I will upload this video
Thank
later.
you.
Yes,
No
thanks
problem.
again. All right,
Now,
bye-bye.
make sure to get the reviews done so that we have it, so we can make any improvements on our part on either the tech side or myself or the chemistry or physics, whatnot. We can make some changes and help maybe future students even get even the better side of us. And so make sure to do that, and appreciate it if you can do that.
All right, thank you.
All right, thank you all. Good luck. And this is the last time I'll see you officially through a Skype session, but I'll be in touch via email. And any questions you may have, concerns, don't forget to email me. We're still in the course. We're not done yet.
Okay, thanks.
All right, get the homework 7 to me tonight is a deadline, and the quiz is due tonight as well. I have answered a lot of the questions through this session, so you should be able to get the homework 7. Get that to me, and then the redo is due on Friday midnight, because as I said, I have very little time to turn around and give the grade. So I gotta be ready except for the final one. All right?
All right,
See you
thank
later. Good night.
Bye.